Welcome back to iMachine Learning class. Before learning specific machine learning topics, we'll first have a quick review of the Python programming language. Python is the easy to learn high-level programming language. Many good features of Python help to win popularity for this programming language. Furthermore, many open source machine learning and data science Python packages have been created over time. Therefore, Python is nowadays the most commonly used programming language for machine learning. In this class, we're planning to use Python 3. Python 2.7 is a long-time stable version of Python. However, Python 2.7's end of life date is set to be 2020, so it makes sense for us to embrace Python 3 now. Learning a programming language is somewhat similar to learning a natural language. First of all, nobody knows everything about a language or stored in their memory. However, the more you use it, the better you have become at a language. A huge part of learning a language is to learn from others' examples. Of course, dictionaries and manuals is a good source to look up to. I'm going to spend 2 sessions to quickly review the Python language. With this much time, I will only be able to cover the nutshell core content of the programming language. Of course, you can continue to learn and continue to deepen your understanding through online resources and, more importantly, your own hands-on work. Most importantly, by now, everyone in the classroom should have the Anaconda package installed already. We're going to use the Spider Interactive Development Environment, aka IDE, and the prompt window that go with the Anaconda for the class. So as we walk through the Python basics, you're going to use the Spider, IDE, and the prompt window. So here is the plan for the Python review. In today, we're going to cover some of those topics, and in the next session, we're going to cover the remaining topics. You might be curious who created the Python programming language and how it was created. Well, Python was created by Guido van Rossum, a Dutch programmer. I hope I pronounced his name correctly. It was started at a Christmas break as a hobby project. The creator chose the name of Python for the new programming language because he was a big fan of the British comedy Monty Python's Flying Circus. Now we're going to learn the basic syntax for the Python program. One thing to emphasize before anything else is indentation is very critical to Python program. Now let's first run a hello program to get a sense of how to execute a Python program. We're going to do that in 2 ways. The first way is to run it through the Spider IDE. The second way is to run it from the prompt window. One benefit of having Anaconda package is it deals with the path settings for you already, so you do not need to have concern or actual work for that. Now let's do it. So the way you find your spider is go through the program list, and you can find it under the Anaconda. And this another one is the prompt window. So I already have the prompt window open, and I know I have a bunch of program under the directory. I want to run the hello program, which is here. the way to run it is typing the command python, then the program name hello.py. So the program runs. It's very simple. Just prints out 3 lines. Hello Python 1, 2, and 3. And that's it. Another way to run the Python program is through the IDE. I also have the IDE open. I actually want to run the Hello program from the IDE. So what I can do is I click on this button, run button, and it runs through. So I'm getting the output here, which you can see are identical to the output I get from the prompt window. So this is another way to run it through the IDE. The benefit of running the IDE is in the IDE you can have different mode, such as debug mode. In the debug mode, you set up the breakpoints. One way to set up breakpoint or clear the breakpoint, just double click the mouse. And another way is put the cursor here, you could debug and you click on F, click on this button and also set up the breakpoint. So run the debug mode, you click on this button, and what breakpoint means is the program execution will stop and wait for your confirmation before going to the next line's execution. So this gives you the opportunity to inspect the different variables to study the behavior of each line of code. It's really useful for debugging or understanding other people's code purpose. Let's do it. If I click here, basically stop here. If I continue to run, I have to click another button and will continue to run. Eventually, the program is all going through, but you can see it stops at the several times. The first line print hello Python 1 and then stop a second time at hello Python 2, and finally the last line I did not set up any breakpoints. Basically, breakpoint is the debug mode, allows you to inspect the status of variables and to study the behavior of a code. Is really good for debugging and learning purpose. So another critical concept with Python is reserved words. There are certain words are reserved by the Python programming language so that when you declare your variable, you should avoid the clash with those reserved words. They are taken. Your variable should not have the same name or have those kind of reserved words. So to find the reserved words, you can go to the reference material, such as this one, and which clearly lists out all the reserved words that you should avoid. So lastly, indentation on this page. Indentation is very critical to Python program because Python program use the level of indentation to indicate whether certain lines of code is in the same block. The basic rule is for all the lines of code in the same block, they must have the same white space indentation. If they do not agree with each other in the indentation level, it's a syntax error. The machine won't run. The program won't run. So this probably seems to be very confusing. Let's play the game first, then understand more from the code for the game. So this game is called Guess Number. What does is the computer will randomly generate an integer between 1 and 20, and the player need to guess what that number is. So to run it, let me click on this run button. First, ask me for my name. I just enter my name. Now the program generates a random number between 1 and 20. I put something in between, 10. It's too big, I'm going to put something in middle again, 5. Still too big, put 3. And still too big, 2. I guess this must be 1 then. Yes, 1 is the answer for this particular random number game at this round. Well, the true purpose of looking at this game is really understand the concept of indentation. So here is the code for this game. Very simple. So first line, there's no any indentation, there's no white space. Starts from the very left. Same thing for 3, 5, 7, 8, and 10. Now something after 10 is different. Starting with 10 until all the way to 23, we are in the block. This block is called a while block. We're going to learn more about the while later today. Since we're now in the block, the 12 has multiple white spaces. That is called indentation. And 14 also has indentations. It's the same degree of indentation of 12. 16 same. It has indentation same as 12 and 14. 17 is different. You will see 17 has even more indentation. The reason of that is 17 is under the subblock of if. It's one level down of the while block. The 19 going back to the while block is another if condition, and 20 is under the if condition, so has additional indentation. Then 22 going back to the while block level, and 23 is in another if block, has additional indentation. Then after that, the while block is over. Line 25 goes all the way back to the left. And 26 is under the if. There's actual indentation. And 27 going back to the left. And 28 has indentation because it is under the else block. So what if I mess up the indentation like line 14? I purposely decrease the indentation a little bit. Now actually the IDE complains about it. It tells you there's a syntax error with the indentation. If I ignore it, click on run, the program won't run, and it tells you there's an error with the code. The only way to get rid of the error is to make sure the indentation of 14 is same as 12 because they are in the same block, the while block. So what about here, 28? Actually, if I increase or decrease the indentation here, it does not really matter because 28 is standalone by itself, is the only line in the else block. So I can increase the indentation or decrease indentation, doesn't matter as long as I do not completely remove all the indentation, make it become the same level of 28. This is the problem because now 28 is supposed to be under 27, but now it's not. There's no indentation to indicate it is under 27. To fix it, I have to have at least one white space to make the indentation. So I hope now you get the concept of indentation. The rule is for all the lines of code in the same block, they must have the same level of indentation. And for all the line of code in the subblock, another subblock, they also have the same level of indentation. If there's inconsistency across the lines of code in the same block or subblock, it's a syntax error. The program. Now let's move on to the next topic, variable types. So first, what is a variable? Variables are reserved memory locations to store values. When you create a variable, basically you reserve some space in the computer's memory. There are 5 standard data types in Python, and they are number, string, list, tuple, and dictionary. Python makes it easy. You actually do not need to declare the variable's data type because Python will determine the variable type when you assign the value to the variable. So first data type, let's take a look, is number. Number is very easy to understand. We all know that from the math class. If it's a number, it could be an integer, either positive, negative, or 0. In Python 3, there's no differentiation between integer and a long. As you may know, in Python 2 and many other programming languages, the memory space allocation for long typically doubles the memory space allocation for integer. But in Python 3, there's no differentiation between integer and a long. Literally, every integer is long. The second number type is called a float. Float are real numbers with decimal points. The third number type is a complex, basically a number with both real or imaginary parts, or simply just the imaginary part. Again, now let's look at the program to understand the number concept with Python. So the program we're going to run is called print numbers, and here it is. So I'm going to set a few breakpoints, just allow us to have a view and block. So the first block is all integers, like integer 10, 100, a negative number, and basically this is 0 and this is 0. If we click on here and here, so all the bunch of integers are being printed out, and here you can see them. So those are the examples of integer. If we continue, we enter the block of float. Those are just real numbers with the decimal points, 0, 90, and a negative number to the 10th power of 100, and another one with exponent. And all these floats also being printed out here. So those are float numbers example. Finally, we come to the complex part. So we have this complex number corresponding to the output here, only imaginary part, another one only with the imaginary part, and now we have number with both real part and imaginary part. And the following two examples also like that. There's both real and imaginary numbers. So these are the examples of numbers. Basically, you are allowed to have either integer or float or complex with Python's number. String is another data type, standard data type for Python. Basically, string is a sequence of characters wrapped around by quotation marks. Python allows you to have a single quotation, or double quotation, or triple quotation. Single quotation or double quotation are equivalent. Triple quotation are special case where your string can take multiple lines. And furthermore, once you have a string which is a sequence of characters, the Python language allows you to do some operation with the character sequence. You can do either slicing, which means you take a part of the string or substring, or you can do concatenation, basically combining multiple strings into one. When do the indexing or slicing, the first index 0 is the first character in the string, and 1 is the second character in the string. So when you have a negative index like -1, it wraps around. -1 is the last character in the string, and -2 is the second last character in the string. Now let's look at the example to understand what I mean based on the definitions or the allowed operations. So let's open the program which is called string operations. Let me clear the output window. So I have one string called hello world, and then first this code will just print the whole string, and after that I'm going to do some slicing operation and print the string twice, and eventually do some string concatenation. And let's click here and see what happens. So first, this line is coming from here because I print the whole string. Now it come to here. I have a slicing operation which takes the first character with index 0, which is H here. Then this slicing operation takes the third character to the fifth character. Remember, index is off by 1. And with that, what it get is LLO, because LLO are the third, fourth, and fifth characters in this particular string. And with 2, without only 2, the low bound without the upper bound, what does is it will print all the characters starting at the third place. That's why you get LLO world, because this L is the third character, which corresponding to index 2. Then with a -1 as index, it wrapped around, will retrieve the last character, this sign. And a -2 is the second last character, which is this guy here. Sorry, it's the D, second last character is the D, as we see here. Now this multiple 2 means I'm just going to print this string twice. So that's what I got here. And now finally in this example we're doing the string concatenation. So I'm getting this string hello world with another string hello machine learning, and at outcome it prints out hello world and hello machine learning. So hopefully you understand something about strings operation from this little code example. So next topic, list. List actually is the most versatile Python's data type. Basically, list has a sequence of items all wrapped up together by the square bracket. The items in the list can be of different data types. In this following example, The first item is a string, BB1, and the second item is a numerical value, 3.14. And again, the third element is a string again. So they can be of different data types, all mixed together in the same list. So for the string, you can pretty much doing the same kind of slicing or concatenation operations that we just did. I mean, in the list, you can pretty much do the same stuff like slicing and concatenation, just similar to what we did to the string. Let's run the example, list example. So let me see, here is the list example. Here, first I declare a list with a bunch of different elements. Some are strings, some are numbers, integer or real number, and another list with 3 strings as their elements. So again, first print out the list, then doing the slicing, and finally doing the concatenation or print the string, print the list multiple times. And here it runs. So this line corresponding to the print list, it just lists all the elements in the list. Then this guy, index 0, get the first element in the list, which is hello. And this guy will get multiple, the second, this guy gets second, third, and second and third, yes, second, third, and 100 and 2.0. And this guy will get all the elements starting at the third place. So this is the third element, all the elements starting from this position. There's no boundary, there's no upper bound. We'll go all the way to the end. Now this -1, as you can see in the string wraparound, this -1 index gives you the last element in the list, which is this. And this one gives you the second last, and which is this. So that's kind of slicing operation for the list. Now this line just print the list twice. We have a multiple 2, and that's what you see. Now the final operation is concatenation. It basically combines 2 strings into 1. So those 2 strings are this one and this one. So when they all combine together, you see the print of the list is much longer. It has both the first list and the second list joined together, becomes 1. So that's the list and its operations. The next variable type is tuple. Tuple is also a sequence data type. Actually, it's very similar to list. But there are a few differences between a tuple and a list. The first difference is for tuple, you put the elements in the parentheses, but in the list, you put the elements in the square brackets. That's the first difference. The second difference is the values in the list. The elements in the list can be modified, can be changed, but all the elements in tuple, once assigned, cannot be modified. So you may think tuple as a read-only list. The slicing and the concatenation can also work for tuples. And here, let's see the examples. So for the benefit of time, I'm not going to go through every line of code very closely as I did for the list or for other variables, but just want to emphasize you create the tuple by putting the elements in the parenthesis, not the bracket as you did for the list. And so if we click here and similarly we do the slicing, do the concatenation, right? There are many things can be done. So just at the end, I also want to emphasize the point that is in the list, right? Here in the end, I'm creating a list which has those many values, and it's a list because you see we're using the square bracket to wrap around the elements. And then here I am doing one operation, which is I want to make the second element in the list uh, become 10,000. It is originally 100. Then I want to print the list, right? If I do this, let's run the code. So everything here, nothing strange. You already know it. It's about the slicing. So all those blocks are doing the slicing. And then nothing strange or new here either. It just does the concatenation. All right. So lastly, I modified this list. The second element of the list was 100, but after the change, after the modification, it becomes 10,000. As you can see, when we print, it becomes here. So also I have one line of code I put into the comment, right? If I remove the comment, this line of code is going to cause the issue. Why it is issue? Because this one is not a list, it's a tuple. This operation is trying to modify one element in the tuple, right? Make it become 10,000. So this is actually the third element in the tuple, which should be 2.0. But this one, if I try to modify, attempting to modify the third element in the tuple, what's going to happen? Well, this one got into the issue. Why there's an issue? Because as I mentioned, tuple is like read-only list. Once the elements are assigned with values, you cannot modify its value anymore. This is a very fundamental difference. All right, now let's look at the dictionary, the last of the 5 standard data types in Python. Dictionary is like hash table. What does that mean? What does that mean? First, each element in a dictionary is a pair, one key and one value. The keys in a dictionary must be unique. Values do not need to be unique. Once a key is provided, its corresponding value can be instantly returned. It's a very efficient way of finding the value from its key. So that's basically how the dictionary or the hash table works. Syntax-wise, the dictionary elements need to put into curly braces like this. And the elements in the dictionary are paired. In this example, the name is the key, 0 is the value. This is one pair. Age is the key, 7 is the value, another element, another pair. The name is many, and the name is the key, many is the value. So keys in a dictionary cannot be updated. It is called immutable. So the keys can be of data type of strings, numbers, or tuples. List cannot be a key. Why is that? Well, remember, we just mentioned list can be modified. So list is not immutable. So that's why it cannot be the key for a dictionary. The values of a dictionary can be of any type because with the same key, you can modify and change its value. Now let's look into the example. So this is the example we want to take a look. So what it does, first we create a dictionary which is empty. Then we create the first pair. This pair, the key is 1 and its value is first value. And then another pair, the key is a numerical 2 and the value is a string, second value. Then it will print out the value corresponding to the two keys. So this is one way to assign elements in the dictionary. Basically do it one by one. So here is another way to create the dictionary. You put everything all paired up together all at once. First name, key, Kevin. Last name, key, value, Hall, and the code, 1000. So that's another way to create a dictionary, assigns its elements. If we run the program and we come to here, the output. So yeah, in addition to print, assign the values or assign element to the dictionary, and this particular line of code just get all the keys or get all the values from the list. I mean from the dictionary. And here again, get all the keys or get all the values from a dictionary. So that is dictionary and how it works. So we're done with the 5 standard data types. Now let's move on to the operators. Python supports the following types of operators: arithmetic operators, comparison, assignment, bitwise, we're going to just ignore for now, and logical operator, and the membership operator, and identity operators. We're also going to ignore the identity operator. It's just saying whether two objects point to the same memory location is or is not. So let's look at the example. So this is an example. So we'll first look at the arithmetic operator. This is very easy to understand, not so much from our math class, right? We have a plus, we have minus, we have multiplication, we have division, and we have a modulus, which returns the remainder if we do integer division, and this is exponent, right? Then let's just run it. Yeah, this block has all the arithmetic operators. because A equal to 10, B equal to 3, if we do the math, pretty much we can get those results. And also, yeah, I forgot to mention there is some other operation, which is floor division. If you do both numbers are the positive numbers, this essentially just returns the quotient. But if one of the numbers is a negative number and also there's remainder, in this case, like minus 9.2 divided by 3, you may get actually the number will be like minus 3 point something, but the operation, the floor division will move this down and returns minus 4. So that's how it works. So those are the blocks of code for the arithmetic operator. This should be pretty easy, straightforward to understand. So the second blocks are the comparison operators. So this is equal, right? If A and B are really equal, then this returns true. And here we see they're not equal because A is 10 and B is 3. So that's why here you got the false. And this is not equal because 10 is not equal to 3. A is not equal to B. Then you got the true. And here then A is 10, B is 3. 10 greater than B. This is true, right? So that's why you got the true. And this one is A less than B. This is not true because in our case, A is 10, B is 3. So it's false. Now you have this like greater than or equal to or less than or equal to, but you get it. This basically compare the relationship between two values. Assignment is very easy to understand as well. You just make A plus B, in this case, becomes C, right? So because A is 10, B is 3 so far, the C should be 13, and 13, that's what has been printed out. So now we moving to the logical operator. So logical operator, there are only 3 types, either and, commonly used types, either and, or not. And is if now I change the value of A and B to Boolean values. A is being assigned to be true and B is assigned to be false. If I want to see and, right, the only condition for and to be true is both are true. Here is not. Here's not because one of them is true, the other is false. But or, yeah, or is okay. As long as one of them is true, then or is true. And that's what I got for this one. And not just negation. If something's true now becomes false. If something's false now becomes true. Because A is true, not A is false. And B is false, not B is true. So that's what you see for the, this is what you see for the logical operators. Lastly, this covers member operations. So this actually works for a bunch of stuff, sequence data like list, string, tuple. What does is you ask whether one item is within the sequence of items in the data variable. In this case, I define a list which has 4 elements, 38, 4, 10, and A is 10, B is 3. Now their value changed. Now ask if A is in the list. Yes, A is 10 is in the list. It's true. Is B in the list? No, 3 is not in the list. It's false. And A is not in the list. That's not right because 10 is in the list. So that's why this is false. And B is not in the list. That's right because B is 3 and 3 is not in the list. So basically those are the operations, basic operations with Python programming language. let's go back. So the language also has priorities. One different operators put together, certain operator take priority. For example, we have 2 to the exponent of 5, then times 3. And because exponent, the power 2 to 5 power has priority, so the operation will do this power calculation first before doing the multiplication. And here's another example. The multiplication has priority over plus. When I have 3 times 5 plus 2, the multiplication will happen first, then do the addition. If you go online, you should be able to find the precedence of the operators. But I think, to keep it simple and avoid memorizing all the orders, priorities, avoid the confusion or mistakes, put the parentheses around of your operators or operands is an easy, simple way to do and good exercise. Now let's move on to the next topic, decision making. In Python, decision making is to test if a condition holds or does not hold. In other words, if a test condition is true or false. So when it's true, do something. When it's false, do something different. There are a few different flavors of decision making. So the first flavor, the simplest one, is if block. How it works. First, you have a test expression. If this expression is true, it flows to here. There's a bunch of operation in the if block. However, if the test condition is false, it just jump out, does nothing, just totally bypass the if block. So the first flavor is called if. The second flavor of decision making is if and else. Here again, you have a test expression. If it's true, go into the if body, if block. If it's false, you have a separate body for else to do. In the end, they all merge, get out of the if and else block. So this is the second flavor. The third flavor is if, else, if, and else. Again, start with the if condition. If it's true, come to the if block. If it's false, you'll ask the second question, which is else if. In the Python syntax, it was spelled as ELIF. If this condition path, you have a separate block for the else if condition. And if fails, it comes to the ultimate else block. Eventually, go through all the conditions and come to the code which is behind and parallel to the if, else if, and else block. So those are the three flavors of decision making in Python programming. Of course, you can get things nested. What that means is, in the if, else blocks, you can further embed other ifs and other else, right? That becomes a nested if statements. Now let's go back to the guess number game again, because that code has decent amount of if block in it. Let's see. So here's the code. So we actually have 3 if blocks in this code, right? The first is say if the guess number, the player's guess is less than the computer generated random number. If that's true, come to this print statement. Then there's another independent um, if test, which says if this guess is greater than the number, this line will be executed. Eventually, if the number is identical to the guess, there's a break. So we'll talk about break later. Essentially, break is associated with the loop. So when break happens, it just jump off the loop. In this case, it's a while loop, because unless you get the identical number between the unless the guess is equal to the number, so the um, the player will have multiple chance to repeat their guess, right? So that's how the loop works. And under this particular if condition, because the guess is equal to number, it jump out and finish. Then here we'll also see another example of if and else, right? Here, if the guess equal to number, saying kind of good job, you get the right guess, then else just saying you did not get it right. So this is an example of if and else. So now if you look at the code carefully and think a little bit, you may realize the three sequential if blocks in the game can be and get something get something equivalent, um, like by doing the if and else break, right? You do not need to have three sequential ifs. You can get the equivalent outcome result by doing if else. So this is a particular example of, and certain times you can get equivalent logic by using different ways of doing the decision making in the code. So the last topic we're going to cover today is on the loop, right? So loop again is a block of code which allow the repeated execution as long as the conditions are met. For the loops, there are two flavors. One type of loop is called a while loop. So first, you just enter the while loop. If the condition is true, you do the execution based on the body of the while loop. If it's false, just leave the loop right away. There's nothing to do because the condition is false. This is called the while loop. The second type of loop is called a for loop. Basically, it just iterate through a sequence. Let's see, you have a list. You have multiple elements in the list. It's just going through the list element by element, items by item. As long as it's not reaching the end of the last element, it will continue do the operation, okay, do the work as specified in the body of the for loop. And once the last element has been reached and handled, the loop is over. It just exits the for loop. And as we see just previously in the guess game code, right, there's an early termination by break. Typically the break, whether you want to enter the break, whether you want to do the early loop termination, is driven by a condition like with the if test. If certain condition is true, you allow the early termination. Let's go back to look at the code again. So in the guess number game, as long as the number of guess is less than 6, right? It starts with 0. Every time when somebody guesses the game, the number of guess will be incremented, will be increased by 1. There's an incremental of 1. And basically the program allows you to guess up to 5 times, right? So So that's how the while loop works. However, in the while loop, also there's a break. The condition to trigger the break is there's an early termination from the while loop if somebody gives the guess equal to number even has not reached the 5 times of guesses yet. So basically this is one example of while loop with the break with the early termination. Now let's also look at another example for the for loop. As I mentioned, the for loop is just like traverse through a sequence. The first sequence I'm putting here is a list. In this list, there are 3 elements, basically 3 sports: tennis, basketball, and swimming. So when come to here, for each sport, in sports, I print one line like I like that sport. I like tennis, I like basketball, I like swimming. Then another example, I'm using string because string is also a sequence of characters. What does is it take each letter in the string and print one letter at a time. So let me clear the output page and run the for loop. Just as I told you, it go through each sport and print out the like this sport, and then go through each letter in the string and print current letter one by one. HELLO. That's for loop. Well, by now we essentially finished all the topic that I prepared for today. Next session, we're going to continue to review Python, and we're going to talk about function, module, class in our next Python review session.